Welcome back. So calculating total mass and the key difference between moles and kind of molecules when you are being asked to calculate the total mass in chemistry related problems from various formulas, which might be, for example, like H2O, which is just water, or many others. I'm going to give you more complicated ones. If you like, to go straight into the examples, you can just timestamp. I'll put a timestamp there for you into those examples. But here I just want to do a little bit of an explanation to give you the distinguishing features. So the video is related to calculating total masses for these various formulas for students who are basically either taking chemistry in some form or maybe some kind of health sciences or sciences in general, or maybe engineering, and they come up to a problem where they're asked to calculate a total mass from an actual formula, right? From a formula for a compound or molecule or whatever it may be, like an H2O. So there's really two key ways, most common ways that are asked for total masses. And they are related to these words that you see when they ask you, how many moles do you have or how many molecules do you have? And I want to give you this distinction because when you see the words moles and molecules, they are actually referring to something slightly a little bit different when it is related towards the mass. When you see a word problem and it utilizes the words moles, then that should be a ring, okay, in your ear that is telling you that the mass that you're going to compute is going to utilize the units of grams. And now grams, for short, I'll put just G. Now, when they utilize the word molecule, okay, or molecules in the actual word problem, then the mass no longer uses grams, but it uses atomic mass units, so AMU. Now you can write atomic mass units if you like in full, but we typically just use the AMU itself, okay, for shorthand. And that is the key distinction when you're going to be running into these problems, and you shouldn't really worry. Now, I'm not going to explain here what the difference between a mole or a molecule is. I'll leave that for the chemistry guys. But what I'm interested in is if you're going to be given a word problem in wherever it is, which field you are, you should be mindful of these words moles and molecules and then how they relate to these total masses. So for instance, okay, if we were doing and trying to find the mass of this H2O molecule. So it's not very difficult, and you probably can look up in the periodic table, what is the mass of a hydrogen, what is the mass of an oxygen, and so on. But I wanted to point out to you that if the word problem utilized and asked you, what is the mass of 1 mole of water, of H2O, then all of a sudden, then you would have been finding, so that means, okay, so I guess we typically write the molar masses as capital M. So I'm going to just write MH. This is the mass of the hydrogen. And again, you can look this up, but I'm going to give this to you. So it's approximately 1.008. But here's the key distinction. It is grams per mole when you're asked about moles. And the mass, okay, so within here, for the oxygen is 16, so approximately 16 grams again per 1 mole. So if you want to find the total mass, so the total mass of this H2O molecule, well, the subscripts always tell us how many do we have of each. So in this case, it tells us we have 2 of the hydrogens, which is 1.008, plus, now there is no subscript on the O, so technically there is a 1 which is hidden there, but we don't really write it, okay, in chemistry. So we would just say plus, 1 times 16, or just simply plus 16 because we know it's 1. And that is it. And now you can go ahead and compute. I'm going to leave the computation to you, okay, which would be around 18.016 grams in total. Now, this total mass is always given to you. Once you compute it, it's in grams because the units of the moles cancel out, okay? Because this is 2 moles, this is grams per mole, so the moles, and the moles at the bottom will cancel, and then this is 1 mole, and this is grams per mole. Okay, and again, so that would cancel, and you just have grams. So you do have consistency when you're adding them up. Now, on the other side, if you were asked to calculate, the mass of one molecule, now you have to be careful because you can't use grams per mole. Now, luckily, the numbers are the same, but here, so instead of writing 1.008 grams per mole, you would write atomic mass units, AMU, per atom. That's the distinction when you're talking about molecules, and that's the distinction when you're talking about moles. And then the same thing, so right here, what you would do is you would write that this is 16, approximately, atomic mass units per atom. Now, very often in these questions, they may drop this per atom that you see right here. It's kind of assumed. So you might see that the mass is 1.008 AMU, but it is per atom, okay, per 1. Now, the calculation again, so in terms of the mass, that wouldn't be any different. So this, you would still have exactly the same thing here. I'm going to duplicate it, except the units now change. And the units here, okay, at the end would have been atomic mass units. That's what I wanted to point out to you in this video. When you're actually trying to compute these total masses, be careful what they're asking you about. Are they asking you about calculating total mass of moles or calculating the total mass of molecules? Let's take a look at a few other examples, which are kind of word problem structured, which hopefully will help you. And I'm going to point out, the keywords moles and molecules, so that it pops out at us and we know which units to use, typically grams or the atomic mass units. So here are some examples that I prepared for you. Okay, so I'm going to take the first example and then we're going to work it out kind of one by one. I'll come back to them. So let me kind of put it here at the bottom of the page. Now, this example is related to sugar. All right, so it says the mighty white sugar. So a sugar molecule is made up of 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. And here is the actual formula right there, C12, H22, and O11. Remember that the subscripts just tell us how many of each. Now, they actually tell us right here, and notice they're using the words atom. And so if they're going to be using the words atom, so it's going to have to do something with atomic mass units. So let's keep reading. Next thing what they say is, what is the total mass of 25 molecules of sugar? So notice what they say. They say, or they tell us, they want 25 molecules. So as soon as you see that molecules, that should be a ring to you that, okay, we're going to be dealing with atomic mass units here. Now, typically you may not necessarily be given what the atomic mass units per atom might be for each, so you might have to look it up in a periodic table, but sometimes maybe your teachers will give it to you. Now, I gave it to you here because I didn't want to glance back and forth between a periodic table. So they tell us that carbon is 12.01 atomic mass units, hydrogen is 1.008 atomic mass units, and oxygen is 16 atomic mass units. That's per 1 atom. So notice they didn't say that per 1 atom, but that's per 1. Okay? So I'm going to write these givens in order to be able to set this up for myself. Let me erase this AMU for now. So what I have is, I have this monster here that they give me. And what they want to know 25 of these. So I know I'm going to have to multiply the actual mass of 1 times 25. And I'll do that in just a moment. So that's the first thing that they give me. Now, what else do they give me? Well, they give me that carbon. Okay, so I'm going to write here that the mass of that was equal to, so 12.01 atomic mass units. Okay, it is per atom, so I'll just write it in there, okay, just for completeness. We know that the hydrogen had a mass of 1.008 atomic mass units per atom. Notice it's all consistent within here, so it's not like they give us grams per mole and atomic mass units per atom. So it's all in atomic mass units. And then the last one is oxygen. And the oxygen was 16 atomic mass units per atom. So we have now the 3 pieces of information that we need for these carbon, hydrogen, and oxygen. And now if I want to calculate the mass, I mean, sure, it is a word problem. So you can say let, M be the mass of, 25 of these sugars that I have. I'm going to probably run out of space here in some way. So let me shrink this slightly. So that's my definition of my mass. And now I can go ahead and compute it. So how many do I have in total? Well, I have 25 of them, right? And now, so I'm going to actually open brackets here. So I technically don't need that multiplication sign there. And now I'm going to go one by one, okay? So I'm going to say I need 12 carbons. Well, 12, each carbon is 12.01. So that's what I have there. Plus, okay, I need 22 of these hydrogens. So that's that. And then finally, I need 11 of these oxygens. I'm going to close the bracket there. And now I have the entire thing that I want. So I can take out my calculator and then compute this whole thing. Now, how you compute it is up to you, right? Just make sure you use the correct order of operations within here. So you can, compute the whole bracket to get 1, if you like. Okay, so I'm going to actually, take this out. And because I am using my calculator, so I'm going to just kind of write it out in full. So 25 times, and then I'm going to put this all in brackets, so 12.01 plus 22 times 1.008 plus 11 times 16, close my bracket, equals. And that gives me the total. I don't know if they asked me round final answer to a whole number. Okay, so if it's to a whole number, so that means I'm not going to have any decimal places. Okay, so that 4, okay, I'm going to remove because I'm rounding, so it's going to be at 7. And now what's the unit? Well, it's atomic mass units. And it's not per atom because we have 25 of these molecules in total. So there is no per atom, it's just atomic mass units now. That's how you would set up this particular example. Let's take a look at another example, which maybe might help you a little bit as well. So my second example within here, so it says, let me copy these down, okay, in here. So it's that one, copy. It's the second problem that we have. A muscle relaxant used to relieve abdominal pain, so Alvarine, has the following formula. So it's C20H27N. I guess those should have been subscripts within here. Let me just kind of write this in subscript form. Okay, so that's the actual formula. What is the mass of 8 moles of these? So notice moles in here. This is really important again. So we have these moles. So now when we have moles, what do we know? We know that we're going to have our mass, our total mass is going to be in grams. And everything else, so per each individual one, so the carbon, hydrogen, and I guess the nitrogen, we're going to be using grams per mole. And that's exactly what they give us. Notice if we continue reading, it says assume that, capital C, which is carbon, has a mass of 12.01 grams per mole. Hydrogen, 1.008 grams per mole. And then the nitrogen, 14.008 grams per mole. Round the answer to the whole number. So in this case, in terms of the setup, if I wanted to bring this out, so given. So again, what I like to do is I like to write down all my givens. So how many do they need in total? Well, they want 8, okay, of these C20, H27, N. And now this carbon, they gave that to us, which is 12.01. I'm going to keep it grams per mole. Just to show the reader what I am doing. Hydrogen, 1.008 grams per mole. And then the last one, which is 14.008 grams per mole. Notice, all the units are consistent, right? They're all grams per mole, okay? This right here is the number of moles that I have, that I need, okay, of that particular, I guess it was Alvarine, okay, so that muscle relaxant that they want me to compute. And now I'm going to say let, so M, so it's still mass, let M be the mass of 8 of these. So that's kind of my definition of what I'm trying to solve for. And now let's compute it. So I'm going to change color here. I'm going to say M equals. I'm going to stick 8 times because I want 8 of them. I'm going to open the bracket. And now I'm going to go one by one. So here's carbon. So how many of these? 20. So that's going to be 20 times 12.01. How many of the hydrogens? 27. It's going to be that. And then how many of the nitrogens? Well, notice there's no subscript, which means, okay, there's only one. And that is 14.08. And now we can go ahead and compute these. So you can individually compute them inside of the bracket. So for instance, you can do all your terms inside of the brackets, compute those, and then add them up. So here this should be plus, okay, so plus, so that's important. Okay, maybe I'll highlight that in right there. But if you're allowed to use a calculator, you can go ahead and punch it all in. So 8 times, open your bracket, now 20 times 12.01 plus 27 times 1.008 plus, and then that's the last one there. And that was just 1 times 14.008. Close my bracket, compute. Now they asked me to round to a whole number, so I will. Notice there's a 3 there behind the decimal, so that means it won't bring up the 1. And this now is in not AMU, but in grams. So be careful there. Make sure that you have the correct unit for the mass. And that would have been your answer. I mean, you can put a closing statement if they ask you to, whatever it is that your teachers ask. So that's another example. That was example number 2. Now, there is one particular formula which sometimes throws students off. So now I hope you understand and see these moles and molecules and then related to either grams or atomic mass units, so it'd be much easier for you to think about. Here is the last example, and this is dolomite, okay, and it is utilized as an ingredient in kind of some ceramics. I guess it's also used in maybe glasses, like glass, I think even brick. So here, so maybe this is, a question from like maybe engineering or something like that, but it doesn't matter. We shouldn't be fearful of these types of questions where we're asked to compute the mass. So the chemical formula, so here it is. So I'm going to highlight it right there. That's the chemical formula. So it's a little bit more complicated. And now what do they ask us? Find the total mass of 120 molecules. That word in itself already tells me it's going to be in atomic mass units, right? And now I can read. Now they give us the calcium, the magnesium, okay, and so on. So the carbon and the oxygens. So we know what they are per atom there. So I can write all of these as givens in terms of setting it up. So I always like, okay, so how many do they want? They want 120. And then I write the formula for myself. Now I have these brackets in the formula, so I'm going to show you how, to deal with this, so you do it kind of correctly, okay? Because brackets in these chemical Formulas actually are very similar to brackets in math in general. So they relate almost one-to-one. So let's write these. So we have Ca, that was 40.08. These are atomic mass units per atom. That's 1. Then we have Mg, so the magnesium, which was 24.305 atomic mass units per atom. Then we have our carbon, which is 12.01. And again, atomic mass units per atom. So everything is consistent, so that's good. And then our oxygen, which is 16 atomic mass units per atom. Now, again, so you can do your definition. So let M, okay, I'll let you complete this. So let M be the mass. Now, what is the mass of? It's the mass of 120, okay, of these. So you can write that in here. And now you can try to set it up. So how would we set this up? What's different about, for instance, these brackets that I have in here? So these ones, how would I set this up? So let me just show you. When you're setting these up, you're going to start exactly the same. So nothing really changes in this way. Maybe, I'll use square brackets here to open, because I'm going to use those round brackets around that CO3 that you see. And now you walk through each individual one. So what I mean by that is, okay, how many of these do we have? Well, we only have 1. So this is 1 times, it's going to be 40.08. Now, plus, how many of these do we have? These Mg. Notice the subscript on that, there isn't one, so that means there's only one of them. It's going to be 1 times, now this is 24.305. Now this is the tricky part, plus. So when they have this, what this is saying is, they're saying that they have 2 of these brackets. So they're saying they have 2 of these brackets. So this is going to be 2. Now it's going to be multiplying because it's a bracket. So that 2 that you see here, that's what I put in here. I put the bracket, and now I walk through these inside of the bracket. So I have 1 of the carbon. I'm just going to write it, instead of saying 1 times, I'm just going to write 12.01. Plus, how many of those oxygens do I have in there? I have 3 of them. So it's going to be 3 times 16. And I'm going to close the bracket. That bracket that you see there, okay, so this bracket right here, okay, is that bracket around. The 2, the subscript, goes in front and it multiplies the entire thing. That's how you would actually try to set it up. Once you've set it up, now it's just a computation. I'm going to move this out of the way. So now you're just going to compute this. Now let's compute it maybe this time around, kind of one by one. And I actually forgot here, we need to put the square bracket so it lines up, right, for the entire thing. So we have 120 times, okay, and then in the bracket, so this is going to be 40.08 plus 24.305 plus 2 times this bracket. Now inside of that bracket, let me take this out in here. I have 12.01 plus 3 times 16. So that's inside of that bracket, which is really just 60.01. Okay, so let me clear that out. So that's much simpler. And now we can go ahead and compute this entire thing if we want to. So 120 multiplied by, I'm going to open the bracket and say 40.08 plus 24.305 plus 2 times what we had in the bracket, which was 60.01. Close my bracket entirely, and there we have it. So it's a huge number. Did they ask us to round? round final answer to the 10th. Okay, so we'll leave it to the 10th like this. And now the question is, what's the unit? Remember, it was molecules, so it's going to be AMU. And that is it. That's how you would set up these types of total mass word problems when you run into chemistry or sciences, health sciences, engineering, or any others. So be careful between moles and molecules. The computations and setups are more or less the same, but the units do change. Thanks for watching. See you in a future video. Bye, everybody.